In mathematics, it is quite easy to generate a long, patterned list of numbers. But when you are tasked with actually adding them all together, step by step, the process quickly becomes a tedious chore. Instead of grinding through endless addition, we can compress this messy problem into a single, clean mathematical symbol. Then we can use a clever mental shortcut, discovered over 3 centuries ago, to calculate the exact total in seconds. To use this tool, you only need one prerequisite. You must already know how to figure out the general rule, or the nth term, for a basic arithmetic sequence. By mastering these concepts, you bypass brute force calculation completely. You learn to handle large-scale addition with professional efficiency. Here's a standard arithmetic sequence: 4, 9, 14, 19. A sequence is strictly a list of numbers, separated by commas. To upgrade it into a series, we physically add the terms. The commas rotate into plus signs, transforming our list into an addition problem. Mathematicians use S sub n for the partial sum of specific terms. We're summing the first 4, so we write S sub 4. When we execute the math and add them together, S sub 4 equals exactly 46. This is the core conceptual distinction. A sequence is the list of numbers itself. A series is the single tangible number you get when you calculate their combined total. To write a series efficiently, professionals use sigma notation. Sigma stands for sum. The bottom variable is the lower bound, your starting index. The top number is the upper bound, your stopping point. The formula to the right is the expression, generating the numbers. The mechanics are straightforward. You plug your starting index into the expression to get your first number. Then you increase the index by 1. Plug it in again, and add the result. You repeat this loop until you hit the upper bound. It is crucial to remember that sigma dictates addition. A common trap is to plug in the numbers and multiply them together. Sigma never means multiply. You are always adding. To prevent off-by-1 counting errors, you can always calculate the exact number of terms in any sigma series. Simply take the upper bound, subtract the lower bound, and add 1. Ultimately, sigma notation is a compact set of instructions. It dictates where to start adding, the pattern to follow, and the exact moment to stop. Let's compress this addition problem. The generating rule is 5n plus 5, with 8 total terms. We lay down a sigma symbol. We set n equals 1 as the lower bound, 8 as the upper bound, and place our rule on the right. We have now taken an unwieldy, screen-spanning addition problem and perfectly encapsulated it into one elegant mathematical package. Now that the problem is neatly written, we still have to calculate the total. Doing that sequentially without a calculator is incredibly slow. There is a hidden structural symmetry. Adding the first term, 10, to the last term, 45, equals 55. Stepping inward, 15 plus 40 equals 55. The 8 terms form 4 matching pairs, each totaling 55. Multiplying 4 by 55 gives our final answer, 220. Recognizing the structural symmetry inside an arithmetic series allows you to hack the problem. You turn difficult sequential addition into basic multiplication. You started out confronting a messy string of numbers. Now you can compress that list into a professional notation and use symmetry to solve it mentally. Here is your challenge for the end of this lesson. Apply this exact Gauss pairing trick to sum every whole number from 1 to 100 on your own. Find the first pair, count how many total pairs there are, and multiply. The logic you use for this 1 to 100 challenge is the basis for the formal arithmetic series formula, the subject of our next video. Remember, higher-level mathematics is not about working harder to crunch numbers. It is about finding the underlying patterns that make the work effortless.